Hello, my name is Haley Watman, and this is my project on the mapping DNA. So, gonna move me over here. First, we're gonna organize and identify the parental and double crossovers. Looking at the data that was given, we organized it in this chart. The highest frequency is the parental class, the lowest is the double crossover recombinant class, and then the middles are therefore the single crossover recombinant class frequencies. It's organized by phenotype, number, and classification. Next, we have to determine the gene order. We must compare the double crossover class to the parental classes, and the gene that differs is going to be considered the middle gene. The parental genotypes that are given are plus and ABC, and the double crossover genotypes are A positive and plus BC. In both genes, there's a swap in the A, as you can see. Therefore, gene A is in the middle. The order of the genes are BAC or CAB. So, we have to determine the single crossovers in the map distance. We use the order BAC to identify the single crossover classes. Positive B positive, 400 is the single crossover between B and A. A positive C is 420, which is the single crossover between B and A. And then positive C, 970 between A and C. And then AB positive 1010 is the single crossover between A and C. I don't know why it has an E there. I'm going to remove that. Okay, notice the numbers are similar in each section. 400 and 420 are close, and then 970 and 1010 are close numbers. This is a very easy way for us to check ourselves. Next step, we have to calculate the distance between BA and AC. So, looking here on the right, this is the formula we're going to use to solve. We do the sum of the single crossover BA plus the sum of the double crossovers over the total progeny, and that equals the recombinant frequency B minus A. Then we multiply the recombinant frequency by 100 to get the distance in centimeters between B and A. Repeat for the other section A and C so that we can get both values. So over here to the left is my description of both. I'm just going to go through one, and then the other is the exact same concept. So we're going to add the number of single crossovers BA together. 400 plus 420 equals 820. And then we do the number of double crossovers. 100 plus 140 equals 240. Then we add these numbers together. Super easy. That's where we did the sum. Next, we divided by the total progeny, which is 5,742. So that's where we divide this sum we just got by the total progeny. And we get 0.1846, which is our recombinant frequency between B and A. Then we multiply this frequency by 100 to get 18.46 centimeters BA. And then we do the same thing for the second one, same exact steps, and we get 38.66 centimeters between A and C. All right, next step, we construct the final map. So it's B to 18.46 centimeters. We get this number here for BA, and then 38.66 AC. 38.66 AC, and that's from using our formula. Okay. Now we're going to calculate the coefficient of coincidence, my bad. So the formula is the observed double crossovers over the expected double crossovers. So to determine the expected, we multiply the recombination frequency B to A by recombination frequency A to C, which we calculated last step. Here we multiplied these two numbers. We see these two numbers right here and right here. Okay? And we get 0.0713. Then we multiply the total progeny of 5,742 to get 410. The second step is we determine the observed, which is easier. It's 100 plus 140 equals 240. Lastly, the coefficient of coincidence must be calculated. So you do the observed over the expected, which is the 240 we got, over the 240 we got here, over the 410, and we get 0.586. Next, we calculate the interference. The interference equals 1 minus the CC, which is